Hey guys, welcome to Code Decode. Today in this video, we are going to cover some Elasticsearch and ELK based interview questions along with the concepts. So if you have no clue about what Elasticsearch is all about, what ELK stack is all about, please be with me in this video till very end and you will be able to answer all these questions in your upcoming interviews for Elasticsearch. Also, please do like, share and subscribe this video as much as possible. We are setting a like target of 1000 likes so that YouTube algorithm will promote this video and this video will reach to all those people like you who are preparing for interviews for Elasticsearch. So let's get started. Let's see what all we are going to cover in this video. We'll be covering what is Elasticsearch. Then we'll be seeing all those companies who are currently using Elasticsearch successfully in their organizations. Why do we need Elasticsearch in the first place? Why not the simple database can work for us? What is the common usage of Elasticsearch in our day-to-day life in IT world? What is cluster? And what is an index in an Elasticsearch? What is document? What are main operations that you can perform on those documents? What is shredding and replica in Elasticsearch? This shredding term you must have came across hundreds of times in an IT world. So today we will see what is shredding in Elasticsearch. What is query language that you will use to query your data that is stored in Elasticsearch? What is the default port number for Elasticsearch and how you can change it? What is the ELK stack? What is the architecture of it? And what are the reasons of using your ELK stack? So we'll be covering all these questions. We also have many advanced topics like what is the data structure which is used by Elasticsearch to store your data. So in indexes in database, we know some kind of tree that is used as an indexing purpose in the normal database. But what is the data structure used for the Elasticsearch internally? Now, what is the internal working of Elasticsearch? This is a very important interview question. So, if you want me to cover all these advanced interview questions also, you have to let me know in the comment section. Today, we are going to start from scratch and see the basics of Elasticsearch. So, let's get started. So, what is Elasticsearch? Elasticsearch is a NoSQL database. Now, you will ask me, we already have many kinds of databases out there. We have relational databases. We also have Cosmos DB for Azure. We also have MongoDB, which is also NoSQL DB. Why now one more database, which is a NoSQL database, that is Elasticsearch. So the reason being, in a normal databases, the search operation is really slow compared to the databases which are created only for the searching purpose. So Elasticsearch is an open source search engine based on Apache Lucene, which uses the inverted text data structure to store its data and it is built with the RESTful APIs because it is created in Java language. Too much of theory? So basic things. First of all, Elasticsearch is needed in this IT world because it is a searched engine. So basically it includes all those features which helps you to faster retrieval of your data and also to store your logs. So the basic utilization of Elasticsearch in our life is to store the logs and to search the backend data with a terrific speed and flexibility. Hence, it is called as a search engine. It is open source written in Java, so you and your organization don't have to pay a penny for this. It is based on a data structure that is inverted text data, which is used for the full text search. That is, even if you write A, all the data with A in it will be, who are indexed, will be searched with it. And you can query it using the RESTful APIs. It mainly consists of three things. The main three things which all of the databases have. It is the index, which is database, the documents, which are the rows similar to the relational database, and fields, which are the columns in the relational database. Basically, in an Elasticsearch, like in a database, what main operations you do? You write and you read. You write in the database when you get some data and you read when you need some data. Similar to that, in Elasticsearch also, you write to the Elasticsearch as soon as your main database is changed or when you have some logs created from your application. Secondly, you read it when you need to fetch logs from your servers. And secondly, you read when you need some terrific speedy search in the backend database. So these are the two operations you always use Elasticsearch. Now, name top 5 companies using Elasticsearch. So, Netflix, Udemy, Walmart, Uber, Slack, Adobe. These are the companies who are successfully using Elasticsearch in their day-to-day life. And they have successfully able to store their unstructured data because it is using the NoSQL, where no structure is needed like the relational ones. Now, why Elasticsearch and what is the common usage of Elasticsearch? So, I've told you two common usages. First is the log, and second is the terrific, speedy, flexible search in the database that you cannot do with a normal database, be it a relational, be it NoSQL, be it a graph database. It doesn't matter. You have a separate search specific databases called Elasticsearch, which enables you to have a very near real time experience of search. Now I'll give you an example of Elasticsearch usage. First is logs. You have multiple logs from multiple places. You can aggregate it and view it. The second thing is the search box or the autocomplete feature. So suppose you are shopping something on Amazon and you want to search a product. So you type a few letters of that product and multiple search options comes here in the drop down. So that search comes from the database backside. If you use a normal database, you might have queries, select star from product table where the product name, like, percent, and your 2-3 words that you have written. When it comes back and returns you must be waiting when my result will come, when my products will be populated in a drop down, and that is very bad. It's very bad user experience. To increase the speed of retrieval from the backend for such kind of speedy retrievals, you have Elasticsearch to rescue. So that's when the normal database hit will make the client wait for a very long time to fetch its data. It actually worsens the user experiences. It is a poor user experience which is not acceptable in the real-time application. Hence, Elasticsearch comes for the rescue. So the most common advantages usage of Elasticsearch is it is very fast, distributed and reliable search engine, which increases the user experience for the auto completion, and also it is a fast retrieval for the logs when you want to see what wrong happened to your server. Why is it not working? What wrong has happened? So that's where the Elasticsearch comes into picture. What is cluster and what is node in Elasticsearch? So let's first understand the node. A node is an Elasticsearch instance. It is a basic instance of an Elasticsearch engine, the server. It is created when an Elasticsearch instance begins. So I'll give you an example. Here my Elasticsearch is up and running in my local. As soon as it is up and running, this is the Elasticsearch.bat. When it is up and running, a instance or the node is created. That node is the instance of Elasticsearch. Now, what is cluster? The collection of such nodes or multiple nodes to hold your entire data in the form of indexes and give you a centralized indexing and search ability across all these nodes forms a cluster. So what is a cluster? Cluster is a multiple nodes together, a collection of nodes, and node is a single instance that depicts your search engine, Elasticsearch engine. And what is document? A document is very similar to a row in a relational database. So let's first see the hierarchy. So in MySQL or any relational database, there is database. Then we have multiple tables inside a database, and then we have multiple rows and columns for each table. Similarly, in Elasticsearch, we have indexes, that is a database. Then we have type, that is table. And then we have documents, which are rows, and properties are the columns. Let me just give you an example. Suppose you have a database called as university. Now university has different type of data. So there will be a list, there will be a table for student, there will be a table for courses available in the university. The students are going to enroll to that particular courses. So all these types will be the tables, and all the properties of such will be the document of into that table. So all the properties will becomes the column, and all the rows will become the each and every student or each and every course in the table. So this is the hierarchy we use in the relational database. Now when you compare to Elasticsearch, each database is an index, each table is a type, each row becomes the document, which is a JSON object, unstructured, and each column becomes the property in that document. Now if you understand the hierarchy, Elasticsearch, you can as an overview, you can see Elasticsearch is nothing but a database, and you can search in the database in a very quick and relaxed format. Now, how will you search? How will you query the Elasticsearch? It will be the localhost 9200, this default port of Elasticsearch. Then you will give the index name. The index name say university. The type say course. And the operation, delete a course, add a course, remove a course, update a course. So basic CRUD operations that you can do. So what are the operations that you can perform on the document? The index of a document, that is to create a document. Fetch of a document, that is get operation. Update a document, that is same in the update in the relational database. Delete a document, something you have very similar to the relational database. So create, get, update, delete, all these things you can perform in Elasticsearch also. Now a very important term, what is shredding and what is replica in Elasticsearch? So you have cluster. In the cluster you have multiple nodes. Each node contains multiple indexes. When index becomes too large, the index is divided into multiple shreds. So if this is your index, you can divide your index into multiple partitions, and each partition will be known as a shred. So data stored in an index running on a node in a cluster can be divided into multiple shreds. So basically shred is a logical division in an index. You can divide your index or the database into multiple shreds. Why do you do that? Because if index becomes very large, it will be difficult to manage and difficult to search. So before the threshold reaches, you can divide and reduce the size of index by shredding. That is by partitioning the index, and each node is capable to index, search each shred separately like an index itself. So with a big index, you can divide it into multiple parts, and each shred will become an index in itself. By default, there are 5 shreds available for an index. For an index, you can easily provide how many shreds you want. As a result, each shred is in its own fully functional independent index which can be searched independently on a node and can run on any of the node in a cluster. Now, what is replica? A replica, as the name implies, is the Elasticsearch fail-safe mechanism. Now, what will Elasticsearch do? If a node is down, then the whole index or the shred is lost. As a backup, what Elasticsearch do is they keep the replica of shreds, because at the end on a node what runs is a shred. So whenever a node crashes, a shred's data is lost. So what Elasticsearch do is to replicate these shreds and keep it as a backup, so that when a node crashes, all these shreds running successfully on a node can be retrieved back. So to ensure the high availability, the replica must not be placed on the same node as the original shred, because the primary shred is capped from which they are replicated from. So it is always said that if you have to make a replica of a shred on a particular node, keep it on a separate node, because if the node is failed, then even your backup will be gone. So keep it on a separate node, so that if the node crashes, you can retrieve the data from the backup node where the replica of these shreds are present. Also, when the request increases, what you can do is you can use that replica shred to serve those read requests back to the client. So this increases the performance. This is why replica is created by Elasticsearch. So these are the two very important terms, shreds and replica in Elasticsearch. Now, what query language do you use to query the Elasticsearch? So the basic language used for querying the data you have stored in the Elasticsearch is Apache Lucene query language, also known as query DSL, domain specific language. Now, since you know Elasticsearch internally uses the Apache Lucene as a search engine, hence the Apache Lucene's query language is used to query the Elasticsearch also. Now, what is the default port number? I've already showed you the default port number is 9200. Now, the very important question, how you can change this port number from 92200 to something like 9300, 9500 or something. You might be using 9200 for your gRPC port number or some other port numbers. So for that, what you can do is you can change this default port number in the elasticsearch.yaml file present in the config folder. So this is my software folder where I have Elasticsearch 7 installed. Here you can see the bin. Here the elasticsearch.bat is currently running on my system. This is elasticsearch.bat running on my system. Here in the beneath that there is a config folder. There is the elasticsearch.yaml file. If I open it here, you can see that this is your cluster name which you can modify. And this is the port number, that is 9200. So you can change this port number to anything which is which like 9300, 9500 or whatever you want. So this is how you can change the port number and the cluster name like you want. So this is the file where you can do all the modifications. This is similar to the properties file you have in your Spring Boot project. Now what is ELK stack? ELK stack is a collection of 3 open source projects. Remember, open source projects, that means you don't have to pay a penny for this. The ELK is Elasticsearch, Logstash and Kibana. These are all developed and managed by a same company called as Elastic. Now, E stands for Elasticsearch. What is Elasticsearch? It is a NoSQL database tool. We have all seen what is Elasticsearch, what is cluster, what is node, what is index, what is document, what is properties. All we have seen now. So, you know that it is a database, NoSQL database search engine used to store your unstructured data and your logs. L is a log stash. It is important. So, let me first show you the architecture. There are many logs on your server. So the task of Logstash is to collect multiple logs from multiple servers, aggregate and transform them into your usage, that is called as data processing, and store it some particular target. So say here the Elasticsearch. So this is the storage unit for your logs on your server. And you want to see your logs. How will you see the data stored in the Elasticsearch? Does the Elasticsearch provide you a UI? No, Elasticsearch does not have any UI provided to you. From where you can see these Elasticsearch's data? You can see it in a Kibana. That is a visualization tool for you. So now Logstash is used for processing and transforming your stored logs. It is a log pipeline tool to transform your data. It takes input from different sources. So we have multiple servers where logs are present. So various transformations are provided on those different sources of data. And lastly, it exports the data to various targets for the storing purpose. The storage purpose is Elasticsearch, which is a database. It is for the data source. It is where you store the data. And it is also used for quick search. Now, it is good for search and get the data, but how can you visualize the data? Since there is no UI for the Elasticsearch, how can you visualize your data stored? So, data visualization tool, you have Kibana and hence the ELK stack, which is providing you the interactive user interface for the data visualization. I have the Elasticsearch and Kibana working on me. Let's see if it is working. So yes, Elasticsearch cluster is working for me. This is the code decode application which is working. I have this created the demo for me for the purpose. If you want to see how this demo is created, or if you want to see the live demo of the Elasticsearch creation, you have to let me know in the comment section. I'll share how this demo is created. And also will share this to the GitHub. Also, you can see the Kibana, the port number for Kibana is 5601. So yes, even Kibana is working for me, and this is the UI tool for your Elasticsearch. So if you hit the Elasticsearch, you cannot see anything. You just see what is your cluster name, what is the compatible version, but you cannot see your data. So how can you see your data? This is the Kibana, which is going to show your data. So this is where you can see your logs, you can see your matrices and have your data exploration happily here. If you want to know more about the Elasticsearch and Kibana, you have to let me know in the comment section. I'll create a live demo for both of these for you. Now the architecture, I already told you what is the architecture. There is multiple servers having the logs. These logs are to be analyzed and identified. So Logstash does the task for you. It collects the logs and events data and parses and transforms it and store it in a database. The database for here is Elasticsearch, which has the transformed data from Logstash as a store, and it can be searched and indexed properly because Elasticsearch is a search engine based on Apache Lucene. Then you cannot see your data as such, so there is no UI. So Kibana is the UI, Visualization and Share Explorer, for the Elasticsearch database. And the reason for using Elasticsearch, as you all know, we have loads and loads of logs available, and as your application increases with the business increases, your logs are difficult to manage and store at a single place. That's where ELK stack comes into picture and helps to your rescue. It works best when logs from various apps can be segregated in the single ELK instance. It provides amazing insight. You can also say it as APM, Application Performance Management, or monitoring can be done with the ELK stack. Also, it is rapid installation. You can see how I can install it quickly on my system, and both are up and running for me currently. It can scale both horizontally and vertically. For index scaling, you have seen for the Elasticsearch. For the scaling purpose, we have shreds which can be stored on multiple nodes, which can be in a single cluster, which can be searched centrally. Hence, the scaling is very easy in ALK stack, and it supports multiple languages. Now, what is inverted stack? What is the terminologies? What is the internal working of Elasticsearch? All you have to know, you have to let me know in the comment section. Also, if you want to know the real-time demo that is currently working for me, you can ask that the same in the comment section. I'll create the demo and all these advanced interview questions also for you. Thank you.